we'll be looking at a little bit more complicated of a circuit here that we have in front of us. It should be pretty easy to reason about if you want to pause the video and work through it. There's just some LEDs wired to different output pins, and then we have a new type of component called a potentiometer, which serves as a dial that we're able to read from. And we'll work through how to use this to light up different LEDs using if statements, and then we'll convert that into some text code instead of block code and start working through that so that we can begin working our competencies with using all of these different functions like pin mode and digital and analog write and read. So first thing I want to do is work through exactly what this potentiometer does. So if I come in here and use my output function to print to the serial monitor, we know how this works. I can add a delay here so that we make sure not to overpopulate our serial monitor. But so if I run this now, as we know, we should just get a bunch of hello worlds printed out with nothing happening on the circuit. If I stop this simulation, I can instead change that hello world to read from the input. So I'll read our analog pin and this potentiometer is hooked up to 5 volts into ground, and then additionally we measure from the dial exactly what we are getting. And if you want to, you can Google this piece, this component, potentiometer, and you'll find some good documentation in exactly how to use this. But so what I want to do now is just show you exactly what this will read. So I can start this simulation, and we start out with this reading of 1023. That's our maximum, but then if I dial that down, I can get all the way down to 0. So what I want to do is basically use this reading here to enable us to turn on the lights in order. And so we know what our maximum and minimum readings are. Oops. While this reloads, we're going to introduce a new concept on top of this as well. We've been working with if statements, but we can also use our variables in block coding. So we can create a new variable called potentiometer reading. And what we can do with this is add a block that sets our potentiometer reading variable to whatever is read from this potentiometer. So here we have it dialed to the lowest level, so it should be set to 0. So at this stage, what I want to do is write a bunch of if statements that will say if our potentiometer reading is less than, let's pick some value. So what I want to do is set this at increments of, there's 6 lights. So if I use increments of, let's see, 100 and 1023 divided by 6 is going to be 170.5. So if I use increments of 170, I'll get up to our desired reading here. So I can use this variable again, our potentiometer reading, and I can tell this block of code to check if the potentiometer reading is greater than our first step, which is 170. And then what I would want to do is, not the built-in, is set the first light, which is our LED, at digital pin 13. I'll set pin 13 to high. So this will turn on our first light if we dial it up above 170 out of 1023. And then I can do the same thing if our potentiometer reading is greater than 340, then I can set our pin the next LED, which is 12, to high. So if we run this code, we'll start out with our LEDs off, and then as I slowly drag this up, we'll get 1 on, and then we'll get 2 on. So if we stop our simulation there, we can jump into the blocks plus text code. So what do we have here? Pull this. I don't think we're going to be able to look at it, but we can at least get the pins into view. So first we have declared this new variable, our potentiometer reading, which has type int. The syntax will become familiar as you write the code. And what we've done here in the setup method, as you recall from the prior video, is we've set our 13 and 12 pins to output, and then we have our analog pin 5 set to input. Then in this loop which runs over and over and over and over again, so it runs through every single line of code and then loops back to the top and runs again, we'll grab the reading from this pin, our analog pin A5, and set our variable potentiometer reading equal to that read. So this is going to be a lot easier to transition to actually writing the code instead of using blocks. So I'm going to switch over. I've abandoned the blocks, and I want to make sure that we set all of our pins. I think we have 6, yep, so we have 11, 10, 9, and 8 as our LEDs, and then I'm just going to keep doing this. So we have 340, 510, 680, 850, and 1020. So this gets all of our readings in here, and we just need to change our pins. 13, 12, 11, 10, 9, and 8. So now if I start this simulation, we have 2 of these LEDs on, and we can turn the rest of them on as well. The one thing to note about this is the way we've written the code, we never actually turn these LEDs off. So take a second to think about how we might do that. We could check at each condition and actually change all of our, we could check that to see if the potentiometer reading is less than a certain threshold and turn those conditions off. What I'm going to do is instead, at the very beginning, change all of these to low. So we have 13, 12, 11, 10, 9, and 8. So now, if we start this simulation, we see that we get just a couple on, and we can turn them up, and then we can also turn them back down. This works because at the beginning of the loop, we set everything to off, but then immediately this code executes and finds the reading of the potentiometer and updates all of those light statuses to what they should be based on that reading. And then this 10 millisecond delay keeps us from ever seeing those lights turn off. So take a minute to poke around with this on your own Tinkercad, and if you'd like, I can give you a potentiometer as well, and you can go ahead and try to wire this up yourself.